Today, hopefully we're going to put the fun in functions. Yeah, I know that's bad, but that's all I got right there. So, introducing functions today. They are on the XY plane. It deals a lot with X and Y values. It's just going to look a little different. Before we get to functions, we need to discuss something called relations. Okay, a relation is just simply a set of ordered pairs. So it could be something like -5, +3. It could just be X and Y. It could be 7, 10. I'm going to just make up anything. I'm gonna do this though to kind of show something. And then it can be -5, +1. And so there's not really any rule that says how you're getting from the X to the Y. So what we're going to do is we're going to put this down here on this mapping diagram at the bottom. Okay, now first of all, everything I put in this first bubble right here is going to be my domain. And everything I put in my second bubble is going to be my range. And my domain is simply exists of all my X values. So it'd be like the -5, the 7, the X, I'm -5. I don't know, I'll just make up something else there, like 1. Doesn't really matter. Okay. While the range is the second component of my ordered pair, also known as the Y value. So these are all my Y values, like 3 and Y, and 10 and 1. There might be a -17. Just making stuff up right here. And like I said, for a relation, there's not a lot of rules. So the -5 up there, it went to the 3. The 7, it went to the 10. Oops, my arrow got shorted there. The 1, I just made up, so I'll just have it go to my other made up number. There's not any rules like this. Like the -5, it also wanted to go to the 1 over here. So the X goes to the Y. It's just a mess of numbers. There's not really any rules for how to get from the domain to the range. And so what we're going to do is we're going to make it so there is one rule. This is a hilarious commercial. I'm not going to play it because it'll make my video way too big to post. But definitely check this out on YouTube with this guy. I'm trying to take off his shirt. Okay, so it gets the point across that there is one rule. Okay, and that one rule for my relation is that each X value leads to exactly one Y value, or each input goes to exactly one output. And that's going to be the theme today. So I like to show this with a toaster. My friend showed me this. It's a great illustration of what has to happen. Now, the number one thing besides Pop-Tarts to put into a toaster is bread. All right, I love toasted bread. Put a little bit of garlic salt on there. Man, it is delicious. But the thing is, whenever I put the bread in the toaster, it's only allowed to come out as one thing. When that bread comes out of the toaster, it has to be toast. I'm a really bad toaster on. Maybe that's just jelly or something on there, or it's just the toasted part of the bread. But it has to come out as toast. I can't have the bread come out as something else other than toast. It can't come out as sometimes it comes out as bread, and maybe another time it'll come out as lasagna or something like that. That cannot happen. Okay, so whatever goes in leads to exactly one output value. So that's what we want to do most of the day to day. Use this function notation and be able to tell whether or not different relations are functions. For example, this one. Okay. I just snapped a picture of the Lemonade House and Grill here in Dexter. They're appetizers currently. I don't know if these prices are still good now or whenever you're watching this video, but this is what they were whenever this summer, whenever I was making my notes. Now the wording on this, don't get caught up on the wording. Okay, it's asking, is the price a function of the appetizer? Okay, so whatever comes first right here, this is my range. This is my second bubble, all right? While this would be my domain. So it's asking, does each appetizer on part A right here, does each appetizer map to exactly one price? Well, I'm looking at it, I have all these different appetizers. Man, they all look so good. I could really go for some mozzarella cheese sticks right now. But even if I look at the mozzarella cheese sticks, they're going to be $5.99. They don't map to any other price other than $5.99. Therefore, it is going to be a function. Well, what if I'm looking at the other way? What if all this over here was my domain and all of this over here in the green circle was my range. We go ahead and do that. Domain now is price. And the range is appetizer. I'm looking at it. Does all of my prices map to exactly one of these appetizers? So example, the $6.99, it maps to the big loaded fries. Those sound good too. But also, if I look down here, $6.99 also maps to this. That is a no-go. You are not allowed to have the same number over here go to two different appetizers. So this one would be a no. Now I'm going to try to use the same wording on this. You can go ahead and try this one on your own. Hit pause on the video. Then, just like usual, we'll come back and see if we map up. So you got yes on these. I really feel as if I would have went further down on this list of the top 5 mathematicians of all time. Maybe I would have been number 6 or 7, Kurt Lovelady up there, but it's hard to compete with these guys and what they came up with math. So maybe next time, all right? Maybe next time. So let's try this just strictly with numbers and x, y points like we've been working with. Now remember my rule. Each input has to go to one output. So let's just go through these tables one by one and figure out which ones work. Each input has to go to one output. So if I'm looking at all these inputs, I notice that they're all different. And so like the -1 goes to 5. There's no, the -1 doesn't go to any other number. And if I look down this input list, it's follows suit for all these numbers. The 2 goes to the 7, and that's it. 2 doesn't go to any other number. So I'm good on this. Even though I have the 1 going to the 4 and the 3 going to 4, that's perfectly legal since the 1 isn't going to something else other than 4. It's going to the 4 and nothing else. So it can be kind of tricky on that. So on this one over here, on the upper right here, looking at it, I'm just kind of scrolling through my input values. I'm making sure each input maps to exactly one output. Ooh, first thing I notice on this is that it's got a couple 4s on there. So what happens is the 4 is mapping to the 7 and the 4 is going to the 14. That is a no-go. Let's go back to our toaster. That's like putting in bread and it coming out toast. And it's like putting in bread and it comes out as a loaded baked potato. Ooh, that sounds good as well right now. So that cannot happen. So this one would be a no. Okay. Looking down here at this last example down here, I don't see any of those x's mapping to 2 different y's. First of all my x's are different, so I didn't even get a chance to. So we'd be back to a yes on that. Okay. So some of these in your homework I want you to do. You probably see one on your homework quiz coming up soon. Now, whenever we're dealing with graphs with these, it gets a lot easier. Okay. A lot of people today have heard of the vertical line test. The vertical line test just simply says that if we can draw any vertical line that intersects a graph more than once, then the graph does not define a function. Because, and then I just restated my definition of function right here. Each output can only have one, has only one output for each input value. So every input has to go to 1. So let's make some up here. That always works well. Here's some that I've had good success with today. Maybe just a straight line right here. A straight line. Vertical line test says as long as I can draw a vertical line anywhere on this graph and it only intersects it once, I'm good. Well, yeah, that happens on this. Okay. Let's try another one. Let's try U right here. Ooh, we have a problem on this U right here. There's several spots I can draw a vertical line and it intersects more than one time. Let's have this make sense. So what I did was I went to the left 2 to this x value. And this x value came out with 2 different y values on this red graph. That's a no-go. The bread went in and came out as toast, and the bread went in and it came out as a ribeye steak. Ooh, that would be good as well. Okay, let's try one more. Let me erase all this. You try this green one. We won't even pause the video. Just think in your head, yes or no. What would that be? Would that be a yes? Would that be a no? A couple spots look kind of fishy on that, but it works. It works. No matter where I draw a vertical line, it's only going to intersect it in at most one place. We're going to do a lot more with the part 2 of this video as with functions and function notation. That will be in tomorrow's video. But for today, I just want to get you used to seeing this f of x right here. And I am calling that f of x. It is y is a function of x, where x is going to be my input values. My input, it's my domain, it's all my x values. Okay, most of the time it's x. Whereas the y and the f of x all together here, either one rather, that's going to be my output. So we write them all concise and nice together right there. Okay. So I got example 5 down here. It says a function. I'm going to switch my letters around so you can't just jack the answers off the top right here. N equals f of y. That's going to give the number of hairs on Mr. Lovelady's head, which is n. And then the y represents a given year. So if I was to say f of 2018 equals 81, I want to know what that represents. I want you to write a sentence as to what that would mean, okay, in context of this problem. Well, looking at this, this 2018 is in the same spot as this y, where the y, let's switch colors, I hate using green. The y is a year. So I could say something like, well, in 2018, oops, 2018. Okay. Now what this is equal to, this 81 right here, that's my output. In 2018, that's telling me how many hairs are on my head. That's my n. So we could say Mr. Lovelady, it's currently 2018, so Mr. Lovelady has 81 hairs on his head. That'd be a great sentence to kind of summarize what that function notation means.